Dear students, today I take up electricity topic of class 10 CBSE. The topic is electricity. We'll be dealing with current electricity in this chapter. Current electricity basically refers to charges in motion, and charges are when any object has imbalance of uh, electrons and protons. As long as electrons and protons in a body are equal, there is no charge. So whenever any electron deficit is there, a positive charge is created, and excess of electrons in a body creates negative charge, and the current will flow when the electrons or charges are in motion. Basically, electrons tend to move from negatively charged a terminal to a positively charged terminal, because they will always move from where they are excess to the place where they are in deficit, from a higher concentration to a lower concentration, pretty much as it happens in a diffusion. So we talk about the charges. You all know positive and negative, and charges will flow when there's a circuit, and basic electric circuit provides a pathway for the flow of current. And circuit basically has a source of current, battery in the form of a battery or a cell, or it will also have conducting wires, a switch that will turn the circuit on and off. When the switch is closed, the current in the circuit is flowing. When the switch is open, the current in the circuit stops flowing, and there has to be a device which we are operating in the circuit, otherwise there is no point in having the electric circuit. And that device could be an electric bulb or a fan, or we can call it a resistor. So this is the basic thing that you need to know about electricity. Now when we talk about current, please understand current is the rate of flow of charges, and current is depicted by letter I, and the formula for current would be charge upon time, where charge is depicted by Q and time T, and T is represented in seconds. So when we say uh, current of 1 ampere is flowing through a circuit, we are basically referring to the amount of current flowing through a conductor when 1 coulomb of charge flows through it in 1 second. So let's talk about current. The definition for current would be rate of flow of charges. Formula for current would be charge upon time. It is represented as I is equal to Q upon T. Q stands for charge, I stands for current, and T stands for time. And when we measure the current, it is measured in amperes. 1 ampere would be coulomb upon second. We are basically trying to say that 1 ampere is the amount of current flowing through a conductor when 1 coulomb charge flows through it in 1 second. So that is for ampere. And when we want to know about how much is 1 coulomb is the collective charge of 6.25 into 10 raised to power 18 electrons. You should know that one electron has got 1.6 into 10 raised to power minus 19 coulomb of charge. So when we are talking about how much is 1 coulomb, we can simply use unitary method to calculate. So if 1.6 into 10 raised to power minus 19 coulomb equals 1 electron. So 1 coulomb would be 1 upon 1.6 into 10 raised to power minus 19. So let me calculate that for you. That will be 10 upon 16 into 10 raised to power 19. I'm going to borrow a 0 to get 100 upon, and then I am left with 10 raised to power 18. So on calculating, obviously we'll get by 4 if it goes. So it will be 6.25 into 10 raised to power 18 electrons. That will constitute, together they will constitute 1 coulomb charge. I hope that is clear to all of you. The next term that we talk about is potential difference or voltage. And potential difference is the reason why the current flows through a circuit, because it creates the like a difference in the potential, or it's similar as it is. We have negative terminals where there is electrons in excess, and there's a positive terminal where the electrons are deficit. So electrons tend to flow from negative to positive terminal, and the difference that between the terminals is the potential, electric potential between the terminals is termed as potential difference. We also know call it as voltage. And more the potential difference, greater would be the flow of current. And when we have to do some work in moving the charges in an electric field, and the amount of work done and the charge moved, that is the voltage or potential difference. The formula is voltage is equal to work done upon charge moved. So V equals W upon Q. V stands for voltage, W stands for work done, and Q would stand for charge moved. So electric potential, potential difference, voltage, they are going to be calculated by using the same formula. Unit for all these would be volt. 1 volt is the potential difference across the ends of terminal of a device if it of a circuit, if it allows 1 coulomb of charge to pass through it by doing 1 joule of work.